When preparing for recessed floor outlets before a concrete pour, you have several options. Firstly, the stubbing conduit and wire method. Secondly, the attaching box and duct tape method. And thirdly, the conduit-only method. Let's examine each one. With option 1, stubbing the conduit and wire, you'll begin by running conduit and wire from the electrical panel to where you want the recessed floor outlets. Leave the conduit and wire sticking up at the height of the finished floor. Make sure you cap the ends of the conduit. This prevents dirt and other materials from getting inside. This first option is generally favored when you might need to slightly adjust the exact placement of the outlets after the concrete has been poured. For option 2, the attaching box and duct tape method, start by attaching the electrical box to the conduit. Then lay the box down flat on the ground where you're going to pour the concrete slab. Take off the cover of the box and use duct tape to seal the box shut. The duct tape protects the inside of the box from concrete. You should leave about 2 inches of the conduit sticking up above the box that's been duct taped. Mark the location and measurements of the box on the ground so you can find it later. This second option is best when the exact spots for the outlets are already known. But remember, there's a chance the concrete won't break away cleanly where the box was taped, which could make it harder to find the box. With option 3, the conduit-only method, run the conduit to where you want the recessed floor outlets. Leave the conduit sticking up at the height of the finished floor. Cap the ends of the conduit to keep dirt and debris out. Don't put in the electrical box until after the concrete is poured. This third option is the most adaptable. Just be sure to carefully install the boxes so they are level and in the right spot. Here are some extra tips. Use rigid metal conduit, or RMC, or Schedule 40 polyvinyl chloride, or PVC, conduit. This will make everything stronger. If you go with option 1 or option 3, use a hammer drill to make holes in the concrete for the boxes. If you choose option 2, use the concrete saw or chisel to make the recesses for the boxes. No matter which option you pick, make sure the boxes are level and even with the finished floor, and protect the wires and boxes from getting wet while the concrete is being poured. To summarize, option 1, stubbing conduit and wire is common. It is good when you might want to move the outlets a little after the concrete is poured. Option 2, attaching the box and duct tape, is less common. It's good if you know exactly where you want the outlets. Be aware of the risk of not being able to easily locate the box after the pour. Option 3, conduit only, is the most versatile. Just be careful to install the boxes correctly and level. Remember to consult local electrical codes and regulations for specific requirements in your area. It is also recommended to consult with a qualified electrician to ensure safe and compliant installation practices. When working with electricity and concrete, safety should always be the top priority. Now let's delve deeper into the specifics of each method, providing more detailed instructions and considerations for a successful recessed floor outlet installation. Beginning with option 1, stubbing conduit and wire, this method offers flexibility and ease of adjustment after the concrete pour. Firstly, determine the precise locations for the recessed floor outlets based on the layout of the room and the intended use of the space. Consider factors such as furniture placement, equipment locations, and accessibility requirements to ensure optimal outlet placement. Secondly, run the appropriate size and type of conduit from the electrical panel to each outlet location, following all applicable electrical codes and regulations. Use rigid metal conduit or Schedule 40 PVC conduit for durability and protection against physical damage. Secure the conduit to the building structure using appropriate supports and fasteners to prevent movement or displacement during the concrete pour. Thirdly, stub the conduit and wire up to the finished floor height, leaving sufficient length for connection to the electrical box. Use a conduit bender to create smooth, gradual bends in the conduit to avoid kinking or damaging the wires. Fourthly, cap the ends of the conduit with appropriate fittings to prevent dirt, debris, and moisture from entering the conduit during the concrete pour. Use waterproof caps or plugs for added protection against moisture. Fifthly, after the concrete has been poured and cured, use a hammer drill to create holes in the concrete for the electrical boxes. Carefully position the boxes and secure them to the concrete using concrete screws or anchors. Sixthly, pull the wires through the conduit and connect them to the terminals in the electrical box, following all wiring standards and safety precautions. Use wire connectors or terminal blocks to ensure secure and reliable connections. Seventhly, install the recessed floor outlet cover plate, ensuring it is flush with the finished floor surface and securely fastened to the electrical box. Use a level to verify that the cover plate is level and aligned with the surrounding floor. Moving on to option 2, attaching box and duct tape method. This approach is suitable when the outlet locations are known with certainty before the concrete pour. Firstly, accurately determine the locations for the recessed floor outlets and mark them on the ground or formwork. Double-check the measurements and alignment to ensure precise outlet placement. Secondly, attach the electrical box to the conduit using appropriate fittings and connectors. Ensure a secure and watertight connection to prevent moisture from entering the box. Thirdly, lay the box flat on the ground where the slab will be poured, positioning it at the marked location. Use shims or spacers to ensure the box is level and flush with the finished floor surface. Fourthly, remove the cover of the box and thoroughly duct tape it shut to protect the box from concrete intrusion. Use multiple layers of duct tape to create a strong and waterproof seal. Fifthly, leave about 2 inches of conduit exposed above the duct tape box, providing a visual reference for locating the box after the concrete pour. Mark the location and measurements of the box on the ground or formwork for easy identification. Sixthly, after the concrete has been poured and cured, carefully locate the buried box using the marked measurements and visual references. Use a hammer and chisel or concrete saw to carefully break away the concrete around the box, taking care not to damage the box or conduit. Seventhly, remove the duct tape and any remaining concrete debris from the box. Inspect the box for damage and replace it if necessary. Eighthly, pull the wires through the conduit and connect them to the terminals in the electrical box, following all wiring standards and safety precautions. Use wire connectors or terminal blocks to ensure secure and reliable connections. Ninthly, install the recessed floor outlet cover plate, ensuring it is flush with the finished floor surface and securely fastened to the electrical box. Use a level to verify that the cover plate is level and aligned with the surrounding floor. Finally, considering option 3, conduit-only method, this option provides the most flexibility for adjusting the outlet locations after the concrete pour. Firstly, determine the approximate locations for the recessed floor outlets and run the conduit from the electrical panel to those areas. Leave the conduit stubbed up to the finished floor height, providing sufficient length for connection to the electrical box. Secondly, cap the ends of the conduit with appropriate fittings to prevent dirt, debris, and moisture from entering the conduit during the concrete pour. Use waterproof caps or plugs for added protection against moisture. Thirdly, after the concrete has been poured and cured, determine the exact locations for the recessed floor outlets based on the final layout of the room and the intended use of the space. Consider factors such as furniture placement, equipment locations, and accessibility requirements to ensure optimal outlet placement. Fourthly, use a hammer drill to create holes in the concrete for the electrical boxes, carefully positioning them at the determined locations. Secure the boxes to the concrete using concrete screws or anchors. Fifthly, pull the wires through the conduit and connect them to the terminals in the electrical box, following all wiring standards and safety precautions. Use wire connectors or terminal blocks to ensure secure and reliable connections. Sixthly, install the recessed floor outlet cover plate, ensuring it is flush with the finished floor surface and securely fastened to the electrical box. Use a level to verify that the cover plate is level and aligned with the surrounding floor. No matter the selected option, using rigid metal conduit or Schedule 40 PVC conduit is an important consideration for the durability of the installation. Rigid metal conduit offers superior protection against physical damage and is suitable for applications where the conduit may be exposed to heavy loads or impacts. Schedule 40 PVC conduit is a cost-effective alternative that provides good protection against corrosion and is suitable for applications where the conduit is buried or protected from physical damage. Ensure that the conduit is properly supported and secured to the building structure to prevent movement or displacement during the concrete pour. Additionally, it is crucial to protect the wires and boxes from moisture during the concrete pouring process. Moisture can damage the wires and electrical components, leading to corrosion, short circuits, and other electrical hazards. Use waterproof caps or plugs to seal the ends of the conduit and protect the wires from moisture intrusion. Wrap the electrical boxes in plastic sheeting or waterproof tape to prevent moisture from entering the boxes. Consider using a concrete admixture that reduces the permeability of the concrete and minimizes the risk of moisture migration. Furthermore, proper grounding is essential for ensuring electrical safety and preventing electrical shock hazards. Ground the conduit and electrical boxes according to the requirements of the National Electrical Code, or NEC, and local electrical codes. Use grounding bushings and bonding jumpers to ensure a continuous and reliable ground path. Connect the grounding wire to the grounding terminal in the electrical box and to the grounding electrode system of the building. Additionally, it is important to carefully plan the layout of the recessed floor outlets to minimize the risk of tripping hazards and ensure accessibility for users. Position the outlets in locations where they will not be obstructed by furniture or equipment and where they can be easily accessed for plugging in and unplugging electrical devices. Consider using recessed floor outlet covers that are flush with the floor surface to minimize the risk of tripping hazards. Also, ensure that the outlets are accessible to individuals with disabilities in compliance with the Americans with Disabilities Act, or ADA, accessibility guidelines. When working with electricity and concrete, safety should always be the top priority. Wear appropriate personal protective equipment, or PPE, including safety glasses, gloves, and footwear. Disconnect the power supply to the electrical circuits before working on the wiring. Use insulated tools to prevent electrical shock hazards. Follow all safety precautions and guidelines provided by the National Electrical Code, or NEC, and local electrical codes. Consider hiring a qualified electrician to perform the electrical work if you are not comfortable or experienced in working with electricity. Remember to consult local electrical codes and regulations for specific requirements in your area. It is also recommended to consult with a qualified electrician to ensure safe and compliant installation practices. When working with electricity and concrete, safety should always be the top priority.